All right, welcome to lesson 3. All right, we're going to continue our quick review over some basic concepts here, including today we're going to go over something called combining like terms. Now, I want you to think about something like more applicable to real life. Okay, so say it's Halloween night, you just went trick-or-treating, right? You got a whole big sack of candy, and you get back to your house, and if you do what I used to do, you dump it all out on the floor, and then in order to assess it properly, you associate the candy with each other. You move all the candy that's the same to each other, right? I move the Hershey bars over here, the Twizzlers over here, the Kit Kats over here, right? The Starburst, whatever you got, right? But I move them all into their own little separate piles so I can see what I have, right? That's because I put them all together. They were like candies, so I put all of the like things together, right? The similar thing is going to apply to math. If something is the same, we can add them together. If they're different, we can't, right? Like I wouldn't take the Twizzler and put it in the Starburst pile and say, wow, look at all this Starburst I got, because those aren't all Starburst, right? So we're gonna do that the same way. It's gonna be heavy vocab today. We're gonna go over this pretty fast. You can see I already have this written up here to save some time, right? But you should follow along on the note sheet that's attached to this lesson so that you can fill in with me, right? First thing we gotta talk about is, if we're saying combining like terms, well, we have to establish what a term is, right? So, a term is a group, that's your first line right there, a group of numbers between an addition or subtraction sign. It's pretty much just saying a number, a variable, anything like that in math class is going to be a term, right? Terms can be a couple of different things. Terms can be a single constant. A constant would be a number just by itself, right? So the example we have written there is 5, right? 5, 12, 18, 46. All of these numbers are a term, they're just by themselves. The second thing a term can be is just a variable by itself. Right, any variable, x, y, z, q, r, p, anything like that, right? Or it can be numbers and variables multiplied together, right? If it's 5x, 12y, 13z, any of these things would count as terms, okay? So any of those are terms. So we're gonna do these 3 examples here of counting terms so we can see exactly just how many terms things have. Remember, a term is everything between an addition or subtraction sign. So all we're going to do for these is we're going to count how many separate things there are, right? -2 in example 1 is the first term. We have a subtraction sign here. So then 3x is its own separate term, that together. We have another subtraction sign, so x squared is another term. And then lastly, just the plus x by itself is a term. So I had 1, 2, 3, 4 terms in the first one, right? First practice, we've got this big long thing, but just break it down the same way. -2x is a term, 5 is a term, 3x is a term, 1 is a term, x squared, 2x squared, and x. So if I count all those, 1, 2, 3, 4, 5, 6, 7 terms in that next one, right? Last one. -2x minus 4 plus x squared minus x minus 2x squared, right? This big long thing. But again, all it's asking us for is how many terms are in here, right? So, -2x is a term, 4 is a term, x squared, x, 2x squared. So that is 1, 2, 3, 4, 5, 6 terms. Okay, that's how you identify terms, and now we're going to go into how you add. All right, 3 vocab words that we need to know for today and for all of algebra going forward, right? The first we've kind of already touched on, right, is variable. That's the entire basis of algebra, right? We have the letter or a symbol that represents a value that we don't quite know yet, some unknown value, and we're going to solve for that most of the time, right? So an example would be anytime you see a letter, right? X, Y, Z, P, R, Q, any of that, right? Second word is more important and a little different, right? It's a coefficient. It is the number multiplied or divided to a variable, right? So it's the number that's right next to a variable if there's no addition or subtraction. So the examples, it says to circle the coefficient. So in 5a, 5 is the coefficient, right? This means 5 times a. in 1/2 x, 1/2 is the coefficient. That means 1/2 of x, 1/2 times x. Last vocab word here is the constant. It is a number without a variable, a number just totally by itself. Right? It's got no variable with it. So p plus 4, the 4 is a constant. It's by itself without a variable. 3x minus 7, just the 7 is the constant. And 5 plus 2a would be the 5. Okay, now we get into the actual combining of the like terms, right? So terms are like terms and can be combined when they follow two rules, and you gotta follow these two rules every single time. Right? The first rule is that they have to have the same variable. They have to have the same variable. So you can only add x's to x's and y's to y's, right? Just like the candy that we said, right? You wouldn't add Snickers and Starburst together because they're different. You can't combine them, they're not the same. Right, so in the first example here, 2x minus x, we can actually do that, right? It's important to remember what's in front of the x, the coefficient on the x is a 1, really. So this is just 2x minus 1x, so that would be just 1x or x, right? Example 2, it counts if the variables are combined like that, like they're all multiplied together. So 2xy minus 6xy, you have xy in both, so you can subtract those or plus negative those. Remember, we're doing that now. So 2 plus negative 6 is negative 4, and you just leave the variables that they have. So xy comes over. Example 3, 5x and 3y. Can you simplify that? Can you add those together? You have an x here and a y here, so you can't add them. Right? So this really, you can't simplify that any further. So that's just 5x plus 3y, right? It's not 8xy, it's not 2yx, it's not anything that you might be tempted to do. Just 5x plus 3y, can't do it. All right. Practice 1 there. 4x plus x. Again, we have x's, so we can add. That just becomes 5x. Practice 2, 5ab plus 2ab. Those are both ab's, so you can add them together. That becomes 7ab. And then practice 3, 2x plus 2y. Again, I have a y and a y. I can't add those together. I just can't, even if you might want to. So 2x plus 2y. That's what it stays. Okay? Second rule. The variable one is probably the easier one. Second rule you got to pay closer attention to is that they have the same exponent on the variable. Right? So in example 1, so you want to ask yourself these two questions every time. In example 1, 2x squared plus x squared. Do I have the same variable? Yes. Do I have the same exponent on the variable? Yes. I have x to the second, x to the second. So all I do is add the numbers in front. Remember, that's a 1. So 2 plus 1 is 3, and I keep the variable and the exponent. So that just becomes 3x squared. Everything else stays just 2 plus 1. Example 2, 2p to the third minus 3p to the third. Do I have the same variable? Yes, I have p. Do I have the same exponent? Yes, I have to the third. So I can combine these. 2p to the third minus 3p to the third. 2 minus 3 is negative 1. P to the third comes with us. Example 3, 2x squared plus 3x to the third. Do I have the same variable? I have x's in both, so far so good. Are they both raised to the same exponent? This is to the second, this is to the third. So no, I can't combine these. So you can just rewrite it the same way it was. We can't add those together, so we're not going to. And of course, example 4, 2a squared plus 2b squared. Do I have the same variable? No, that's your instant clue, right? Cannot combine. So you can just rewrite 2a squared plus 2b squared. Okay, now we're going to go over the 4 steps to actually solve one of these problems and really simplify it when it's a longer version and not just those simple ones that we were doing, right? So if I have this one, that's the example given here, 5x plus 3p minus 4x minus 6p plus 5. We have 4 easy steps, and they're written there, and you can follow along. Right? Step 1 is going to be keep, change, subtraction to addition. That's going to be our first step for pretty much every problem this entire year. So I have this subtraction, I'm going to change that to plus negative 4x, and I have this one then I'm going to change to plus negative 6p. So if I go to rewrite this, 5x plus 3p plus negative 4x plus negative 6p plus 5. I didn't change anything, I just changed that to a plus negative, okay? Now step 2 is going to be rearranged so that all the like terms are next to each other, so it's going to make it really easy for us to see. All right, so really what I'm going to do is I'm going to move this x over, and I'm going to put that by the other x. I'm going to move the p over and move that by the other x. So now I'm going to have 5x plus negative 4x, so moving that over, plus 3p plus negative 6p plus 5. So now I have my x's together, I have my p's together, I have my constants. If I had any more, they would be together as well. All right, now, this third step is one we're going to introduce right now, and I hope we get rid of over time as we get more comfortable and better at doing this. But if you draw 3 kind of circles, we're going to put all the x's into one circle, all the p's into one, all the constants in another. So that's what it means by the bubble. So if you put 5x over here, negative 4x in, 3p, negative 6p, and then 5. They each have their own because they're all like terms, right? You get your x's, you get your p's, you get your constants. Now the last step would be to combine these by adding just what's in the bubble. So all you focus on is the bubble. So 5x plus negative 4x would just be 1x. 3p plus negative 6p would be negative 3p. And 5, there's nothing to combine with, so you just leave that. Oh, I missed the 3. That's my fault. There was a 3 in all these problems, right? So there should have been a plus 3 at the end, so there should be a 3 here. 5 plus 3 is going to be 8. Hopefully you follow along with me on that. But you put them together just like that, so you get a final answer that's already printed there for you. X plus negative 3p plus 8. Okay, we're going to do 2 more examples and then we're done with it. Okay, 2 last practice problems following our 4 steps. First step was keep, change, change. In this first one, we only have this minus 5a squared. We're going to change that to plus negative. So I'm going to rewrite the whole thing. 3a squared plus 4a plus negative 5a squared plus a plus 9. Make sure we're careful when you're copying these things to make sure that you're copying everything correctly, right? Now, rearrange so that all the like terms are together. So I have a squareds, I'm going to move those together. So it's going to become 3a squared plus negative 5a squared plus, I got 4a, I got another a, and then I got a 9, which doesn't have another constant with it. Step 3, if you want to, is to make these bubbles so we can combine easier and visually and we can see. So the a squareds go together, the a's go together, and then the 9 is just by itself. Last thing you do is you add these together and then you're done. So this is negative 2a squared plus 5a plus 9. All I do is add the circles, add the circles, add the circles. Okay, last one. b minus 3c plus 2 minus 3b plus 4 plus 5. Okay, again, change all subtraction to plus negative. And you can see why it's more important on these because we're moving things around. Right, so b plus negative 3c plus 2 plus negative 3b plus 4 plus 5. All right, I'm going to rearrange so that my b's are together, my c's are together, my constants are together. So I'm going to have b plus negative 3b plus negative 3c plus 2 plus 4 plus 5. Okay, now I'm going to make my circles again. Again, if you don't need to do this part and you can just add straight from here, you can see the b's go together, the c's go together, and the constants go together. That's good. That's a better way and a more mature way to do it. 2, 4, and 5 all go in one bubble. So b plus negative 3b, that's going to be negative 2b. We don't have anything for this, so negative 3c. 2 plus 4 is 6, plus 5 is 11. So negative 2b plus negative 3c plus 11 is the final answer, and that is combining like terms.